Now in this lecture we will find the radius of the circle. In the drawing we have a circle, and inside this circle we have quadrilateral ABCD that is inscribed in this by this circle, and we want to find out the radius of this circle that contains quadrilateral ABCD. So first of all, I will present you a new rule. Rule number 1. Rule number 1 states that the area of a quadrilateral that it is inscribed by a circle is suppose that the quadrilateral is ABCD and the length of the four sides of that quadrilateral is ABCD. So suppose we have a quadrilateral we have this circle and inside this circle belongs a quadrilateral and suppose that the length of AB is A units, the length of side BC of quadrilateral ABCD is B units, the length of side DC of quadrilateral ABCD is C units, and the length of side AD of quadrilateral ABCD is D units. Then the area of this quadrilateral will be equal to S minus A times S minus B times S minus C times S minus D, when A, B, C and D are the lengths of the four sides of quadrilateral ABCD, like you see in this drawing, and S equals to the sum of four sides of quadrilateral ABCD. So it is A plus B plus C plus D over 2. Okay? So actually the area of a quadrilateral that it is inscribed by a circle. So the area, this is the sign of the area. So the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of the four sides of quadrilateral ABCD, like you see in the drawing, and S equals to the sum of four sides of quadrilateral ABCD, that is to say A plus B plus C plus D over 2. Okay, so actually, if we define the length of this our quadrilateral, the length of side AB is A, the length of side BC is B, the length of side CD is C, and the length of side AD is D. So according to rule number 1, the area of quadrilateral ABCD, our quadrilateral, again, this is the sign for the area of quadrilateral ABCD. It will be equal to the root of S minus A times S minus B times S minus C times S minus D, and A, B, C, and D are the lengths of the four sides of quadrilateral ABCD, and S equals to A plus B plus C plus D over 2. Okay? And actually we have another rule, rule number 2. According to rule number 2, here we will draw the two diagonals of this quadrilateral ABCD. So the first diagonal will be AC, and we will define diagonal AC as X. So the size of AC is X units, and we will draw diagonal DB, the second diagonal of quadrilateral ABCD. And the size dB will be equal to Y units. According to rule number 2, X times Y x times y, the multiplications of the two diagonals of quadrilateral ABCD will be equal to A times C, the multiplication of the two opposite sides of quadrilateral ABCD, plus B times D. So actually the sum of the multiplication of two opposite sides of diagonal that is inscribed by a circle will be equal to the multiplication of the two diagonals of that quadrilateral that is inscribed by a circle. Okay, so we can write down that the sum of the multiplication of the two opposite sides of a quadrilateral that it is inscribed by a circle equals to the multiplication of the two diagonals by each other. Okay, so I'll read rule number 2 again. Rule number 2 states that the sum of the multiplication of the two opposite sides of a quadrilateral that it is inscribed by a circle equals to the multiplication of the two diagonals by each other. So whenever you have a diagonal that it is inscribed by a circle, then the multiplication of two sides, the multiplication of the two diagonals of that quadrilateral, that is to say x times y, will be equal to the sum of the two opposite sides that are multiplied by each other. This is to say it will be equal to A times C, that is the multiplication of the two opposite sides of quadrilateral ABCD, plus B times D. So x times y equals to A times C plus B times D. Okay, and we also have rule number 3. According to rule number 3, if you have a triangle that it is inscribed by a circle, then the radius of that circle that it is inscribed by, the radius of that circle that it is that blocks the triangle will be equal. Suppose that we have a triangle that is inscribed by a circle, so actually triangle ABC is inscribed by a circle, this triangle ABC is inscribed by this circle, then we can find the radius of this circle by knowing the sizes of the three sides of triangle ABC. Suppose that the size of side AB is A units, the size of side BC is B units, and the size of side AC of triangle ABC is X. Then the radius of the circle that contains this triangle or blocks this triangle will be equal to A times B times X over 4 times the area of triangle ABC. Okay, so again, according to rule number 3, the radius of a circle that blocks this triangle equals to the multiplication of 4 sides of triangle ABC, or the multiplication of the length of the three sides of triangle ABC, that is to say to A times B times X, over the area of triangle ABC, or 4 times the area of triangle ABC. Okay, so we will define so we will use rule number 3. So according to rule number 3, the radius of our circle, that is what we are looking for, according to rule number 3, capital R equals to A times B times X over 4 times the area of triangle ABC. This is according to rule number 3. The radius of this circle that blocks quadrilateral, no, that actually blocks triangle ABC will be equal to A times B times X over 4 times the area of triangle ABC. But we can calculate the radius of this circle also by focusing on triangle ADC. If we focus on triangle ADC, this triangle, the radius of this circle will be equal to C times D times X over 4 times the area of triangle ADC. So, according to rule number 3, the radius of this circle, if we focus on triangle ADC, equals to the multiplication of 4 sides of triangle ADC, that is to say C times D times X over 4 times the area of triangle ADC. And if as you can see from the drawing, the sum of the areas of triangle ABC plus the area of triangle ADC equals to the area of triangle ABCD. So first of all, we will find out the areas of triangle ABC and triangle ADC from those two equations. This will be equation number 1, this will be equation number 2. According to equation number 1, we will multiply equation number 1 by the area of triangle ABC, and we will get then the area of triangle ABC times the radius of the circle equals to A times B times X over 4. Here we will divide this equality by R, the radius of the circle, and we will get that the area of triangle ABC equals to A times B times X over 4R. So we'll do the same process on equation number 2, and we will get that we have equation number 2 that states that the radius of the circle equals to C times D times X over 4 times the area of triangle ADC. Okay, so this is equation number 2. And we will multiply equation number 2 by the area of triangle ADC. And we will get that the area of triangle ADC times R equals to C times d times x over 4. So here we'll divide equation number 2 by r, and we'll get that the area of triangle ADC equals to c times d times x over 4r. Okay, we found out the area of triangle ADC, and we have already found out that the area of triangle ABC, according to equation number 1, equals to a times b times x over 4r. Okay, but we know that the area of triangle ABC plus the area of triangle ADC equals to the area of quadrilateral ABCD. So I write it down. We know that the area, question number 3, will be that the area of triangle ABC, this triangle, plus the area of triangle ADC, this triangle, equals to the area of quadrilateral ABCD. Okay, so you can see that quadrilateral ABCD consists of two triangles, triangle ABC and triangle ADC. Therefore, the sum of the two triangles that the sum of the areas of the two triangles that quadrilateral ABCD consists of will be the area of quadrilateral ABCD. So I repeat again on the formula of equation number 3. Quadrilateral ABCD consists of two triangles, triangle ABC and triangle ADC. Therefore, the areas of triangle ABC plus the area of triangle ADC will be equal to the area of quadrilateral ABCD. You can see it from the drawing. The area of triangle ABC plus the area of triangle ADC will be equal to the area of quadrilateral ABCD. Very simple. Okay. So what is the area of triangle ABC? The area of triangle ABC, we have already found out that the area of triangle ABC equals to a times b times x over 4r, and the area of triangle ADC equals to c times d times x over 4r, and it equals to the area of triangle ABCD. So here we will take a common factor of x over 4r. We'll take out the common factor x over 4r out of this equality, and we will get that x over 4r equals to a times b plus c times d, and that is actually the area of quadrilateral ABCD. Okay, so we took out a common factor from this expression, a common factor x over 4r from this expression, and we got that x over 4r times ab plus cd equals to the area of triangle ABCD. So I write again that the area of triangle ABCD, according to equation number 3, equals to x over 4r in the brackets we have A times B plus C times D. Okay, this will be equation number 3. The area of triangle ABCD equals to x over 4r times AB plus CD. Okay, so in the next step we will repeat on the same process for y. We will implement rule number 3 on if we focus on triangle BDC. So actually triangle BDC is inscribed by this circle. Therefore, according to rule number 3, the radius of this circle, according to rule number 3, will be equal to, we focus on triangle ADC, BDC, this triangle BDC, the radius will be equal to B times C times Y over 4 times the area of triangle BDC. I will repeat again. If we focus on triangle BDC, this triangle, according to rule number 3, we have this circle that blocks this triangle. This triangle is inscribed in this circle. Therefore, according to rule number 3, the radius of the circle that blocks triangle BCD will be equal to B times C times Y over 4 times the area of triangle BDC. Okay, in the next step we will focus on triangle ABD, this triangle, and according to rule number 3, if you focus on this triangle that it is inscribed by this circle, then the radius of the circle that blocks triangle ABD, this triangle, will be equal to A times D times Y over 4 times the area of triangle ABD. And repeat again, if you focus on triangle ABD is inscribed by this circle. Triangle ABD is inscribed by this circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABD will be equal to the multiplication of 4 sides of triangle ABD, that is to say A times D times Y, A times D times Y over 4 times the area of this triangle, triangle ABD. Okay, so now we'll repeat on the same process as we did on X. We will find out the areas of triangle BDC and triangle ABD from those equations. We will define this equation as equation number 5, and this equation is equation number 6. So according to equation number 5, Actually, we will multiply equation number 5 by the area of triangle BDC, and we will get that the area of triangle BDC times the radius of the circle equals to b times c times y over 4. This is according to equation number 5. So here we will divide equation number 5 by r, the area of the circle that blocks triangle BDC, and we will get that the area of triangle BDC equals to b times c times y over 4 times the radius of the circle that blocks triangle BDC. Okay, so we found out the area of triangle BDC. In the same way, we'll find out the area of triangle ABD, that it is inscribed by this circle. So for equation number 6, we will actually multiply equation number 6 by the area of triangle ABD. So the area of triangle ABD times the radius will be equal to a times d times y over 4. Okay. Here we will divide equation number 6 by r, the radius of the circle, and we will get that the area of triangle ABD equals to a times d times y over 4 times the radius of the circle that blocks triangle ABD. So here is equation number 6. And from equation number 5, we also know that the area of triangle BDC equals to b times c times y over 4r. But we also know that the sum of the area of triangle ABD plus the area of triangle BDC, the sum of the areas of those two triangles, it is exactly the sum of the area of triangle ABCD. So we can write down that the area of triangle, or the area of quadrilateral ABCD, it consists of two triangles, so the area of triangle ABCD will be equal to the area of triangle ABD plus the area of triangle BDC. Okay, so the area of quadrilateral ABCD equals to the area of triangle ABD that we found out that is actually a times d times y over 4r plus the area of triangle BDC that equals to b times c times y over 4r. So we actually found out that the area of triangle ABCD equals to a times b times y over 4r plus b times c times y over 4r. Here we'll take out a times b over 4r is a common factor of this expression, and we'll get that the area of triangle ABCD equals to, so here y over 4r is a common factor of this expression, and inside the brackets we will have a times d plus b times c. Okay, we found out that the area of triangle of quadrilateral ABCD equals to y over 4r times AD plus BC. So we will define it as equation number 1, that the area of triangle ABCD equals to y over 4r. In the brackets we have a times d plus b times c. And we have already found out that the area of triangle, the area of quadrilateral, this will be question number 2, the area of quadrilateral ABCD equals to x over 4r times AB plus CD. Okay, we have two equations, two different equations for the area of quadrilateral ABCD. In the next step, we will multiply equation number 1 by equation number 2. So we'll get equation number 3. That is to say, it is actually the area of triangle ABCD squared will be equal to x over 4r, y over 4r, AD plus BC, and AB plus CD. Okay, actually that is equation number 3, the multiplication of the area of triangle ABCD equals to this expression. 4r times 4r is 16r squared, and here we have x times y, so we'll write it down. 4r times 4r is 16r squared, so the area of triangle ABCD, or we will actually take a root. First of all, the area of triangle ABCD square equals to x times y, AD plus BC, and AB plus CD over 16r squared. 4r times 4r is 16r squared. So here we will take a root out of this equation number 3, and we will get that the area of triangle ABCD equals to the root of this expression, that is xy times AD plus BC, AB plus CD. Actually, the root of 16r squared, first of all, the root of 16 is 4, and the root of r squared is r, so it is actually in total 4r, or the root of 16r squared is 4r. So here we will multiply equation number 3 by r in order to find out, we want to find out the radius of the circle. So we get that 4 times the area of triangle ABCD equals to the root of xy AD plus BC times AB times CD over R. So here we multiplied equation number 3 by R, and we got this. It is actually, we will multiply this equation number 3 by R, and we will get that R times the area of triangle ABCD equals to this expression over 4. So after we multiplied this expression by r, we got that the radius times the area of triangle ABCD equals to this expression over 4. Here we will divide equation number 3 by the area of triangle ABCD, and in this way we will get the radius of the circle that we are looking for. Okay. So the radius of the circle will be equal to the root of x times y AD plus BC AB plus CD over 4 times the area of triangle ABCD. Okay. First of all, what is x times y? According to rule number 2, x times y equals to AC plus BD. Okay. According to rule number 2, x times y equals to AC plus BD. X times y equals to AC plus BD. Here we have, if we multiply according to rule number 2 the diagonals of quadrilateral ABCD that is inscribed by this circle, x times y equals to AC plus BD. So here we will substitute x times y in equation number 3 by AC plus BD, because x times y equals to AC plus BD, and we will get that the radius of the circle that blocks quadrilateral ABCD equals to the root of, instead of x times y, we will write down AC plus BD. We have AD plus BC, and we have also here AB plus CD, and all divided by 4 times the area of triangle ABCD. According to rule number 1, the area of triangle ABCD according to rule number 1, the area of triangle ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. That's all. That is the area of triangle quadrilateral ABCD, and we know that S equals to A plus B plus C plus D over 2. Okay. So we will calculate the area of triangle ABCD in order to put it inside this equation number 3. Now, okay? So we actually know, according to what is given us in the question, that A equals to 3 units, BC, that is B, equals to 4 units. We also know that DC equals to 5 units, and AD equals to 6 units. So I write it here that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. Okay, so first of all, S will be equal to 3, A plus B plus C plus D is 3 plus 4 plus 5 plus 6 over 2. 3 plus 4 is 7, 7 plus 5 is 12, and 12 plus 6 is 18. 18 over 2 is 9. So we found out that S equals to 9. S equals to 9 units. So now we can calculate the area of triangle ABCD. So the area of triangle ABCD equals to the root of S is 9. So it is actually 9 minus 3 times 9 minus 4 times 9 minus 5 times 9 minus 6. So the area of triangle ABCD equals to the root of 6 times 9 minus 3 is 6. 9 minus 5, 9 minus 5 is 9 minus 4 is 5. 9 minus 5 is 4. And 9 minus 6 is 3. Okay, so the area of triangle ABCD equals to 3 times 4 times 5 times 6. Okay, that is actually 3 times 4 is 12. 12 times 5 is 7. So we'll do it in the computer. 3 times 4 times 5 times 6. So it is 360. 360. 360. So the area of triangle ABCD is the root of 3 times 60. So in total we will get that the radius of the circle equals to the root of AC plus BD plus the root of times the root of AD plus BC plus AB plus CD, and inside the root also we have 360 and outside the root we have 1 over 4. Okay, so actually the radius of the circle equals to this expression. So the radius of the circle equals to 1 over 4. Inside the root we have, I write it here, that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So here A is 3, C is 5, 3 times 5 is 15, plus B times D is 4 times 6 is 24, times A times D is 3 times 6 is 18, plus B times C is 4 times 5 is 20, plus A times B is 3 times 4 is 12, plus C times D is 5 times 6 is 30, and all divided by 360. So the radius of the circle equals to 1 over 4, and inside the root we have 15 plus 24 is 39, 18 plus 20 is 38, and 12 plus 30 is 42, 42, all divided by 360. So here the radius of the small circle will be equal to 1 over 4, and 39 times 38, 39 times 38 is 1482 times 42 is 62,244 over 360. So we will divide 62,244 by 360, and we got that the radius of the circle equals to 172.9. The root of 172, the root of 172 over 4 units, and the root of 172 is actually 13.149 over 4. So the radius of the circle equals to 3.287 units. Okay, so we found out that the radius of the circle that blocks quadrilateral ABCD equals to 3.287 units. Okay, so that is the answer to the question. I'll repeat again. The radius of this circle that blocks quadrilateral ABCD, or actually quadrilateral ABCD is inscribed by this circle, and the radius of this circle equals to 3.287 units. Okay, so now I will summarize the lecture. Or actually, we can also say that the radius of this circle equals to the root of 172.9 over 4 units. Okay. Okay, so the radius of this circle equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, that is the answer to the question. Now I will summarize the lecture. Actually, we have here a circle that blocks quadrilateral ABCD, or quadrilateral ABCD is inscribed by this circle, and we also know that side AD of quadrilateral ABCD equals to 6 units, side AD equals to 6 units, side AB equals to 3 units, side BC equals to 4 units, and side DC equals to 5 units. Actually, we define AB as A, we define AD as D, we define DC as C, and we define side BC of quadrilateral ABCD as B. Okay? And again, we want to find out the radius of this circle that blocks this quadrilateral ABCD. Okay? Actually, I presented to you 3 rules, and by implementing the 3 rules that I presented to you, we found out the radius of this circle. We have rule number 1 that states that the area of a quadrilateral that it is inscribed by a circle equals to, suppose that we have quadrilateral ABCD that it is inscribed by this circle, and we know that side AB equals to A units, side BC equals to B units, side DC equals to C units, and the size of side AD of quadrilateral ABCD equals to B units. Then the area of this quadrilateral that is actually cyclic, that is to say it can be blocked by a circle, and the meaning of the sentence that a quadrilateral can be blocked by this circle is actually that all of its 4 vertices lie on a circle, and the quadrilateral itself is inside the circle, and all of its 4 vertices lie on that circle. This is the meaning of a cyclic quadrilateral. Any quadrilateral that all of its 4 vertices lie on a circle and the quadrilateral itself is inside that circle, then that quadrilateral is defined as cyclic quadrilateral. So actually in our drawing we have a cyclic quadrilateral because, as you can see, quadrilateral ABCD inside this circle, and all of its 4 vertices, that is to say A, B, C, and D, lie on this circle. Therefore, quadrilateral ABCD is a cyclic quadrilateral. Okay, and the area of a cyclic quadrilateral, according to rule number 1, is actually the area of ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when S is the sum of the 4 sides of quadrilateral ABCD divided by 2 over 2. Okay, so that is the area of any quadrilateral that is a cyclic quadrilateral, that is to say it can be blocked by a circle or a quadrilateral that it is inscribed by a circle as we can calculate the area of quadrilateral that is inscribed by a circle according to this formula. The area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when S equals to A plus B plus C plus D over 2. Okay? Okay? So, therefore, the area of our quadrilateral ABCD equals exactly to the same expression, and S equals to S plus B plus C plus D over 2. So actually that is rule number 1, and we also have rule number 2. According to rule number 2, the sum of the multiplication of two opposite sides of a quadrilateral that is inscribed by a circle equals to the multiplication of the two diagonals by each other. So if we look on this quadrilateral ABCD that is inscribed by this circle, then according to rule number 2, if we draw the two diagonals of quadrilateral ABCD, that is to say diagonal AC is defined, the size of diagonal AC is x units, and the size of diagonal BD of quadrilateral ABCD equals to y units, then according to rule number 2, x times y equals to A times C plus B times D. Again, according to rule number 2, because of the fact that this quadrilateral ABCD is a cyclic, that is to say it is inscribed by a circle, quadrilateral ABCD is inscribed by this circle, therefore it is a cyclic quadrilateral, therefore we know that x times y equals to AC plus BD. Again, x times y equals to AC plus BD. Okay, according to rule number 2, if you have a quadrilateral that is a cyclic quadrilateral, that is to say it can be inscribed by a circle, then x times y will be equal to AC plus BD. Okay, that is rule number 2. And we have also rule number 3. If we have a triangle that is inscribed by a circle, for example, we have this triangle ABC is inscribed by this circle, then we can find out the radius that blocks this triangle by the following formula. The radius of this circle that blocks triangle ABC actually equals to the multiplication of three sides of this triangle ABCD over 4 times the area of triangle ABC. Actually, X is the size of side AC of triangle ABC. A is the size of side AB of triangle ABC, and B is the size of side BC of triangle ABC. And according to rule number 3, the radius of a circle that blocks a triangle equals to the multiplication of the 4 sides of the triangle, that is block that is inscribed by this circle over 4 times the area of that triangle that is inscribed by this circle. Okay? And because of the fact that our in our drawing we have triangle ABC that is inscribed by this circle. So according to rule number 3, we can find out the radius of this circle. That is what we are looking for in this question. We want to find out the radius of this circle. And we know that according to rule number 3, we can calculate the radius of this circle that blocks triangle ABC. And we can also calculate the radius of this circle by the formula, the same for rule number 3, because the radius of this circle also blocks triangle ACD. And we can also look on quadrilateral ABCD as it actually blocks two other triangles. It blocks triangle BCD, and this circle also blocks triangle ABD. So we can use rule number 3 on those two triangles. So actually in total we can use rule number 3 in 4 different triangles: on triangle ABC, on triangle ADC, and we can also use rule number 3 on 2 other triangles: on triangle BCD and on triangle ABD. And in this way we will find out the radius of this circle that blocks those 4 triangles. Okay, so actually if we focus on triangle ABC, according to rule number 3, the radius of this circle that blocks this triangle ABC, will be equal to the multiplication of all 3 sides of triangle ABCD over 4 times the area of triangle ABC. If we focus on triangle ABCD, if we focus on triangle ABC, the radius of the circle that blocks this triangle ABC will be equal to A times B times X over 4 times the area of triangle ABC. That is to say, A times B times X, that is the multiplication of all 3 sides of triangle ABC over 4 times the area of triangle ABC. That is actually the implementation of rule number 3 in our drawing if we relate to triangle ABC. And we can also use rule number 3 by focusing on triangle ADC that is inscribed by this circle. And according to rule number 3, the radius of this circle will be equal to the multiplication of 3 sides of triangle ADC, that is to say C times D times X over 4 times the area of triangle ADC. Okay? The radius of the circle equals to the multiplication of 4 sides of triangle ADC by over 4 times the area of this triangle ADC. This is also according to rule number 3. Then we just found out that the value that the area of triangle ABC, we multiplied equation number 1 by the area of triangle ABC. We got this expression. Then we divided this equation number 1 by r, and we got that this is the area of triangle ABC, and we repeated on the same process on triangle ADC. We implemented rule number 3 on triangle ADC. Again, the radius of this circle equals to the multiplication of three sides of triangle ADC, that is to say C times D times X over 4 times of the area of triangle ADC. Okay, this is rule number 3. And we found out the area of triangle ADC. We found out that the area of triangle ADC equals to C times D times X over 4 times the radius of the circle, and we have already found out the area of triangle ABC. And we know that the area of triangle ABC plus the area of triangle ADC equals exactly to the area of quadrilateral ABCD, because of the fact that quadrilateral ABCD consists of exactly those two triangles, triangle ABC and triangle ADC. Therefore, the area of triangle of quadrilateral ABCD equals to the sum of the areas of triangle ABC plus the area of triangle ADC. Very simple. Okay. I will repeat again, the area of triangle ABC plus the area of triangle ADC equals to the area of quadrilateral ABCD, because quadrilateral ABCD consists of those two triangles, triangle ABC and triangle ADC. Therefore, the area of the sum of the areas of those two triangles is exactly the area of triangle ABCD. Very simple. Okay, so we put inside this equation number 3 the area of triangle ABC and the area of triangle ADC, and we found out that the area of triangle ABCD equals to this expression. Then we actually repeated on the same process, on the two triangles, triangle BDC and triangle ABD. Okay, and we actually found out that actually the area of triangle the area of quadrilateral ABCD equals to the area of triangle BDC plus the area of triangle ABD. Okay. Again, the area of triangle of quadrilateral ABCD equals to the area of triangle ABD plus the area of triangle BDC, and we found the areas of triangle ABD and triangle BDC according to rule number 3. Okay. So in total, we found out that the area of triangle ABD, according to the fact that the area of triangle of quadrilateral ABCD equals to the area of triangle BDC plus the area of triangle ABD, in total it equals to this expression. And we have already found out that the area of triangle the area of quadrilateral ABCD equals to this expression. So we have two expressions for the area of quadrilateral ABCD, and we actually multiplied equation number 1 by equation number 2, and we got the area of quadrilateral ABCD squared. We got this expression, and then we took a root of this equation number 3. We got this expression. The root of 16r squared is 4r. and then we know that we have inside this root we have xy, but we know that xy according to rule number 2 equals to AC plus BD, so we substituted xy here by this expression that equals to xy, and here we know the values of A, B, C, and D. So then we calculated the area of triangle of quadrilateral ABCD. According to rule number 1, the area of quadrilateral ABCD equals to this expression. So we have ABCD, we know the values of A, B, C, and D, and S equals to A plus B plus C plus D over 2. So we have all the data, we have A, B, C, and D, so the only thing that is left to do is to find out the area, to put the data inside this equality, and to find out the area of quadrilateral ABCD. We found out that S equals to 9 units, and the area of quadrilateral ABCD equals to the root of 300 to this, the root of 360. Okay, so the area of quadrilateral ABCD equals to the root of 360. So here inside we substituted the area of triangle of quadrilateral ABCD by 360, and we have also the values of this expression, because we know that A equals to 3, B equals to 4, C equals to 5, and D equals to 6 units. Okay, so we found out that the area or the radius of this circle that blocks quadrilateral ABCD equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle that blocks quadrilateral ABCD equals to 3.287 units. I will repeat again. We found out that the radius of this circle that blocks quadrilateral ABCD equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle that blocks quadrilateral ABCD equals to 3.287 units. Okay, so we have, that is the answer to the question. So quadrilateral ABCD is described by this circle, and the radius of this circle equals to either the root of 172.9 over 4 units, or in terms of numbers, it equals to 3.287 units. Okay, thank you very much.